Thanks everybody for joining, right? This is a big session and it seems like there's a lot of interest in general in this topic, right? Yeah, I mean, if it's not clear enough from the title of the presentation, I mean, today we're going to be talking about really Wi-Fi packet captures, right? And how to interpret them, how to use software like Wireshark to analyze them. We'll talk a little bit about how Ybot, our product, is very great for gathering this data. But really the goal is just to be educational, right? So hopefully everybody can go away with at least a little something that they learned or might be useful in your day to day, right? The agenda for today's presentation. All right, so our key topics, right? First, we're going to talk about basically an intro to packet captures, right? Just to kind of set lay of the land, what a PCAP is, some of the information about that and how to capture them, right? We'll talk about Wireshark. Everybody loves Wireshark, right? So we'll definitely cover some of the tips and tricks, I would say, as well as we go through some ideas, coloring filters, display filters, things like that. We also want to touch on a real world, demo, right? So at that point, I'm gonna hand it over to my counterpart, Adam, and he's gonna run through some examples of actual issues we can see in Wireshark and how to look at that, and then any time is going to be a Q&A, right? With this webinar, there's actually quite a lot of, I'll say, resources that we're kind of pulling together, including, packet capture files to download with examples, uh, some of our links for external resources like the Wireshark download, things like that, the slide deck. So anyway, we have a support page that has all these resources, which is linked here, and then I think Mike probably just linked it to the chat for everybody. So just maybe keep in mind, bookmark that, for after the presentation, and you'll see all the important links. So let's get started, right? Intro to PCAPs, right? I guess this little cute phrase, "P capture didn't happen." I mean, there is some truth to that, right? Packet captures are great because, they generally don't lie. Now, I mean, there are some idiosyncrasies with capturing packets we'll go through to make sure you're getting the correct data and understanding what you're capturing, but at the end of the day, right, packet captures have their place, and it's really about getting to the bottom of things, what is a packet capture, right? So many of you probably know the answer to this in one way or another, but I do like to kind of, throw another angle at it, right? And so effectively what a packet capture is, you have a network interface, right? A wired connection, a Wi-Fi connection, and a PCAP is really just a trace of all the traffic that interface is seeing, and it's actually protocol dependent, right? So if you take a true Wi-Fi capture in monitor mode, you're going to get the Wi-Fi protocol. You take a capture from your Ethernet port, you'll get the Ethernet protocol, et cetera, right? You can take packet captures with all sorts of different communication technologies, right? But in general, in a PCAP, what you're seeing, bit for bit recording, right? So what that means is you get the packets, the ones and zeros effectively, right? Those are all kind of captured, right? And the software you'll use will generally be able to decode that, right? And give you some displays of what you're actually looking at. But it's all the packets. That's kind of the main key. And that would include things like, especially with Wi-Fi, right? Your data frames, of course, but also Wi-Fi only stuff, control and management frames. We'll talk about those as we go through the presentation and what that means. And everything's time-stamped as well, right? So when you're dealing with really time-sensitive events, packet capture is awesome. I mean, you're recording down to many decimal points, right? Below a second. You're able to see the order of these events. So very useful, but very complex, very a lot of data that you're pulling in here, right? So Wi-Fi packet captures are kind of a little bit of a beast, right? That we should explain, and maybe how they differ as well from the more common packet captures you'll deal with, which would be wired, right? So a Wi-Fi capture, how does it work? Well, you're going to need a Wi-Fi radio, which is in something you might hear referred to as sniffer mode or monitor mode. And what it does, right, is it's going to just listen to all the wireless transmissions that happen to be, visible or, listenable, as it were, on that, a particular channel, right? So some quirks with that, right? I mean, you actually don't have to be authenticated to a network to capture traffic from it if you're dealing with Wi-Fi. Very interesting to think about that, right? But if you're in a enterprise environment, and they're using radius authentication, 82.1x, all that. I mean, that doesn't really matter in terms of you're capturing those packets because Wi-Fi is over the air, right? So you can still see all the transmissions. Much of that's encrypted. The data payload, especially, right, is going to be encrypted, but you could still find out quite a lot about what's going on by looking at the unencrypted data, right? And the main thing with the Wi-Fi capture, and the reason you need it in a lot of cases, is actually most, right, of the traffic, packets, frames, whatever you want to call it, that are visible on Wi-Fi are not visible and they're not forwarded onto your wired infrastructure. So if you take a wired capture from the firewall or something, you're going to miss out on the majority of the transmissions that a radio had done, right? You're only going to see the data frames that got forwarded. And then wired captures, right? I mean, so wired PCAPs obviously very useful, and they have their place because you get your data payload, right? And that's still encrypted usually in some ways with like HTTPS traffic, right? That's encrypted, but you could still see much more, in terms of the application layer traffic on a wire. Now you do need some way to kind of intercept that traffic, right? There's a few ways to handle it. I mean, a very common one is to use a port mirror, meaning you'll mirror all the switch port traffic from, port A, and then go to wherever your laptop's plugged in, and then you can kind of see all the traffic going on in that port. Um, and also something interesting to think about, right? When you use a Wireshark on, let's say on Windows, right? And you didn't set up your radio properly for monitor mode, and you go to do a capture on the Wi-Fi interface. What you're really getting is, I guess, a virtual wired capture. So you're seeing kind of all the the stuff that gets forwarded to the wired network, but you're not going to see, like we said, all that management control traffic that's only visible over wireless, right? So that's why Wi-Fi packet captures are important and different in a lot of ways, right? So why do you actually need a PCAP? Well, there's a few reasons, right? But I guess one thing to say, right, is you usually don't need a PCAP, right? I mean, these days the tools you have, be it with Ybot or with your AP vendor or whatever, right? I mean, they're getting better and better, and a lot of the troubleshooting you can do without a packet capture. So when you need to get into a PCAP, well, a few cases, right? One would be when you have like a misbehaving device, you need to really debug and understand what's going on. Well, PCAPs are great for that because a lot of times when something's a bug, right, the pre-coded, UI tools don't really account for things like that, right? So, that'd be like driver problems on your clients. Sometimes clients failing to authenticate or roaming issues where they just, can't even connect to the AP. Firmware issues, right, with the AP, maybe you make an upgrade and then, I don't know, the AP starts doing something weird, doesn't beacon often enough or whatever, right? Packet captures prove that stuff out, right? Verifying config. So, especially from an audit standpoint, if you make a bunch of changes to your wireless settings, right? You set your channel width and, maybe change security settings in SSID or whatever, right? Maybe the UI says one thing, like, okay, the change is applied, the AP is using these settings, but in some cases, you actually want to run a capture to verify, right? To look at the beacon traffic, for example, and see that the AP is actually, set its channel width to 40 megahertz, for example, right? So it's good to be able to verify as well by taking captures, and that's easy to do relatively because, that's beacon frames give you a lot of that data, and those are unencrypted, right? Security events as well, right? So if you're dealing with denial of service attacks, usually that's actually because of misconfigured wireless intrusion prevention systems, right? But in general, right, you'll see those broadcast deauthentication floods, for example, unauthorized connections as well, right? You can see some client trying and failing to authenticate to your network. Max spoofing is an interesting case as well, that you can actually get pretty close to figuring out what's going on with a packet capture with MAC spoofing. So as you might know, right, you can set your MAC address on an interface generally to whatever you want. But one thing packet captures, Wi-Fi PCAPs are cool for, is they tell you the signal strength of those packets. So you can sort of look at that and say, how come I see the same MAC address transmitting from two, 20 dB different signal strength, right? And that can kind of indicate with a little bit of know-how, you can figure out there's some MAC spoofing going on. So interesting case, right? And then I think the biggest one, though, that we hear about is vendor TAC cases, right? If you go back and forth with your Wi-Fi vendor about this or that issue, I mean, the ultimate thing you run into doing is a packet capture. And maybe that kind of ties into our next slide, right? I mean, getting a packet capture can be extremely difficult, right? I mean, because, well, if you look at the equipment you need, I mean, if you have Linux or Mac, you're a little bit better off because those operating systems actually do have native monitor mode support. So you can just, for example, go on Mac OS, enable sniffer mode, take a capture. You don't need to get like special equipment or drivers or anything like that. Windows, it's not as easy, right? It's better than it used to be, but in general with Windows, you need to have a Wi-Fi radio that supports monitor mode, and those are a little few and far between, right? And certainly generally not going to be the built-in radio on your laptop, right? You probably need to get an external USB adapter. Other considerations, though, I mean, with a packet capture, I mean, you got to be really aware. We'll talk about this in the next slide as well of the channel you're on, where you're physically located, when you're capturing the traffic, because most issues, that really warrant this level of analysis are intermittent, right? So you have to be right place, right time. Actually, right place, right channel, right time, right? So a lot of parameters you need to be aware of, and you need to be prepared in order to run a successful capture, right? So you have to know the band and channel that the relevant traffic, usually a client, right, is communicating on. Okay, so you need to figure that out beforehand, right? You need to know the AP. The SSID as well is helpful to know for the situation you're trying to investigate. Obviously, MAC addresses, you need to collect all that. And by the way, these have to be wireless MAC addresses, right? So, most devices have multiple interfaces, so make sure you have the correct MAC address, that you're using. And also the right type of radio, right? I mean, especially these days with 6 gigahertz and Wi-Fi 7, etc. I mean, you have to have a Wi-Fi radio that could decode or even listen to the channels that you're trying to capture on. So, just be aware of this, right? If you're doing captures the manual way with a laptop or even with one of your APs and you put it in monitor mode, I mean, you have to have all this data kind of ahead of time, right? So it's a little bit of a challenge. Now, I guess a segue, right? We do have YBot, right? We have sensors, and our sensors are kind of built for this challenge because they're a proactive monitoring tool. So you deploy the sensors strategically, and they 24/7 are doing packet captures, right? So that makes it much easier because now it's not as much of a reactive, get out there, get all the data, make sure you have the right adapter, et cetera, process. It's kind of ready to go for you, with the YBot technology, right? So, and also they're historically stored, right? So explain that. I mean, so the hardware of the sensors, we have 3 Wi-Fi radios, right? They're in 24/7 monitor mode. And they're configurable, right? What the radios will do. The default state, though, is you'll have one radio listening to a channel based on the closest AP of your network on the 2.4 band, one on the 5 gig band. Those will continuously capture packets. And then we also have a third radio, which is in a kind of a sniffer or a time slicing mode, right? So it goes through all the channels and you can pick up other stuff, right? Neighboring APs and the manager traffic on the other channels that you're seeing, right? So, but the main point, I guess, that kind of stands us apart from the other options you have would be the historical functionality because, you know, as we said, the time domain is very important when you're taking a packet capture. So the nice thing here is you have a buffer on each sensor, which goes back in time. Now, a couple things to say here, right? The included storage by default on your sensors is roughly going to give you about 24 hours of a packet capture trace. And I say roughly because, the number of packets we capture is variable. The amount of storage we have is set, right? So that's going to change effectively how far the buffer goes back. Now that's expandable, right? There's an optional upgrade for the sensors. So if you're in communication with our sales team or anything like that, and you're talking about what to purchase, the upgraded storage is a great option if this is a big thing for you because that takes the storage and expands it quite a lot. I mean, usually it's quite a range, right? But it's somewhere between 7 days and 30 days, right? Is what you'll probably get with the expanded storage. So if you do have YBot, you're a customer and you're curious about how to see this data, go to your YBot dashboard. On the left-hand side, you'll see your advanced tab. And then there's a trace download function, which will open a window that looks like this, where you pick your, your sensor, the one of the radios on the sensor, the date and time of that capture, set a duration, right, a 5 minute, 30 minute, 1 hour, right? You don't have, so if you don't want to capture a full hour, you can kind of narrow it down a little bit. Click retrieve, that'll package it up, and then you can download it. It'll be a .pcap file, which you can then, of course, open in Wireshark and analyze as you will. Okay. And then I guess one other thing to say, well, we're talking about our technology, right? And we'll get back into the Wireshark stuff in just a second. But the YBot approach, what's nice here is we analyze the PCAPs and we sort of call out the significant events within them, right? So that might be, as you can kind of see in this screenshot, right? Like, oh, there's an AP with legacy data rates, or, the management overhead on the channel is too high, right? This is all based on packet capture analysis. So I guess the thing to say, right, is with this data, again, you probably don't need to get into the packet capture yourself because we are sort of fleshing that out for you. But that being said, if you need to validate or debug, or you're working with a vendor or whatever, you can download the capture file. Okay, so that's YBot's approach. Again, I'm sure many of you are customers, so hopefully you already have some of these set up. But if you're curious, I mean, reach out to our team, and we'll be happy to give you some additional info on that. But let's get started with Wireshark, right? Everybody loves Wireshark. Like I said, I'm sure many of you already have Wireshark installed and have probably used it at least to some degree. So yeah, it's a great software, right? And so if you don't have Wireshark though, just a kind of high level explanation, right? I mean, it's an open source, basically protocol analyzer is kind of the fancy name, you would call this type of software is, and it's so freely available, right? Just go to wireshark.org/download. Here's another link, so if you click that, you'll find the download. It runs on really all the operating systems that are common, right? Mac, Windows, Linux, etc. So why is Wireshark so great? Well, it gives you a really nice flexible, user interface for filtering and inspecting and sorting through this packet capture data. It also gives you some efficient, visualization tools, right? You look at data flows and graphs and things like that to kind of show you how much it's good to visualize these things, right? When you're really looking at it at this level. It rebuilds, right, the data, right? Because the raw data of a packet capture is really just binary, right? Your ones and zeros machine code. So this will rebuild that, right, into human readable info, which is that's honestly to me the most impressive part of Wireshark is how it's able to just all these different protocols that it supports, and the way it's able to visualize that is very, very nice. As I said, it runs on all operating systems and it's customizable as well, right? So yeah, Wireshark is awesome. I guess we all kind of are aware of that. Here's what the interface looks like, right? So again, you've probably seen some of this, but just to kind of explain. So Wireshark, you have the top, you have your filter bar, right? And we'll get into this, right? But filtering in Wireshark is a skill in and to itself, and it's probably one of the biggest things to be able to do, right? Is filter down for what you need to see. You have your packet log, right? So this is your kind of list of all the packets that we're seeing. I mean, by default, it's going to be sorted sequentially by time. You can change how this is sorted as well. Down here, you kind of have your decode info, right? So the frame details. So again, I mean, very impressive that Wireshark's able to do this, but it takes all these different frames and it gives you a nice breakdown where you can get into the contents of those frames in a human readable capacity. But you also do get the kind of the machine code, right? The binary. I mean, it's presented as hexadecimal, but in any case, you can see the raw structure of that packet, which in some cases is useful. All right. So the amount of packets, right, that you're capturing, especially on Wi-Fi, is always going to be much more than you need because you see all these other transmissions from every other client, all the other APs on the same channel, and a lot of the management traffic and stuff is effectively noise, for what you're trying to look at or to capture. So, like I said, right, filtering is a very important skill with Wireshark. So there's a few ways, right, you can handle this. One would be using columns, right? We all so with Wireshark, right? I'll back up one frame. Actually, no, we cover this in a different slide, so we'll see visual of it, right? But you can create columns, for the different things within a packet that you're curious about, like RSSI, source destination MAC, packet type. I mean, anything that's in the detailed, packet information, you can make a column out of it, which is very nice, to just sort very quickly. Coloring filters as well, right? That's a big thing. That makes it much easier on the eyes to look at and kind of sift through. And then obviously the filter bar, as we described, is where you're going to put in some queries to filter down for specific packets, right? So here's just an example of a coloring template, right? And why that's nice. As you can see here, we have, our beacons in kind of this blue color. We have maybe a lighter blue for a data frame. And then retries, right? Those are colored red. So now you can start seeing, okay, this is actually some example of a potential wireless issue, and the color makes it a little bit more obvious to see, right? So I guess let's talk about how, Wireshark breaks down a packet, and sort of the structure of that. In this example, we're looking at a beacon frame. So when you're looking at a Wi-Fi capture, the beacon frames are going to be the ones that have, bang for the buck, if you will, right? The most data for just relevant information gathering. It's always good to look at a beacon because it gives you lots of very nice information about the network and, the channels it's using and things like that, right? But here's the structure, right? So you have what's called the radio tap header. Okay, so that's kind of Wireshark rebuilding some of the stuff that the physical sort of wireless connection, the physical radio is seeing, right? And that's things like data rates, right? How fast that frame's been modulated, the signal strength, signal noise ratio in some cases is available, right? But the radio tap header, you can kind of think of that as layer one, right? If you will, the physical layer. The MAC header, okay, that's where we get to layer two, right? That's where you're going to have your source and destination MAC addresses, right? So who's sending it, who's receiving it. With wireless, you get some additional stuff like BSSID, which is telling you basically the Wi-Fi radio of the AP that's in use here. Sequence number. So if you're trying to kind of sort through these frames and figure out if you know, you have some issues with retries or whatever, right? The sequence number is really good for seeing, the order of those packets as they were sent. Type and subtype as well, right? So we'll get into some of the different types of frames you see, but this is where that's determined, right? If you have a management frame, a control frame, a data frame, and then the different subtypes within that, right? And then the payload, okay? So this is where depends on the type of frame, right? So in a management frame, the payload is going to give you a lot of additional information about, so in the case of a beacon, right? The AP config items, right? Your data rate support, channel support, Wi-Fi standards it's using, SSID names, stuff like that. And then when you look at data payloads, right, that's going to contain, the ones and zeros that go onto the wired network, get forward to the internet or whatever is going on. And usually that's going to be encrypted, by the way. So when you're looking at a Wi-Fi capture, unless you have an open network, which, generally you don't see those as often as you used to, but I guess sometimes guest networks are like that. The payload's entirely encrypted. So for data frames, but for management frames and things like that, you'll be able to see a lot of information in that. So the types of Wi-Fi frames you're going to see, there's really three main categories you'll hear referred to, and that would be management frames, control frames, data frames. Okay, so management frames in a nutshell. Okay, and we're not going to cover every single type of management frame here because there's quite a few. But the point of a management frame is to manage the advertisement of the Wi-Fi network, so your clients are able to find it, right? And then also access to the Wi-Fi network to let the clients get connected, associated, authenticated, things like that. Okay. So some examples of those: beacon frames, right? I sort of mentioned those already. That's where your AP's advertising those SSIDs, generally 10 times a second per SSID. Those are being sent out. And it contains lots of information, right? Like we just said. Probe request and response, that's so, that's usually part of the connection process, right? Your clients are going to do probe requests to find out which APs are available, and then the AP is going to send a probe response to give them the information requested. And then you'll see kind of your connection frames, I call them, right? Your association frames, your authentication frames, which is just essentially a handshake, right? To go through and have the AP establish a connection for that client, right? And once it's associated, it's now connected to the AP, and then it can start getting some some unicast frames going back and forth. Other things, action frames, right? So those are sort of miscellaneous functions. Especially as Wi-Fi protocols come out, there's new purposes for action frames all the time. But you have things like beamforming, your neighbor reports. I think there's action frames in use for multi-link operation and stuff like that for Wi-Fi 7. So anyway, kind of miscellaneous, right? And then your disassociation, deauthentication. I mean, that's where you're actually bouncing clients off your network. Almost always that's an innocuous, not something to like be concerned about from a malicious standpoint, but they can have a malicious intent, right? If somebody's doing a broadcast denial of service, that's usually going to be done with deauthentications or disassociation frames with spoofed MAC addresses and things like that, right? Now, control frames are interesting, right? Those are primarily, I would say, to ensure that your traffic's flowing smoothly, right? And there's a couple of them. So you have like your ACKs, right? And there's a few different types of ACKs. I'm not covering all of them here. You have block acknowledgements as well. But the point of it is every time, a unicast Wi-Fi frame is sent, the way the protocols works, right, is to make sure the frame was received, the receiver has to send an acknowledgement back, right? Say, I got your traffic. Okay, you're good. And if that's not received, right? If the ACK isn't received by the client sends it again, and that's a retry. Okay, so that's easy to see in a packet capture. You also have request to send, clear to send. So that's going to coordinate your transmissions, especially in an environment where you have higher than normal, retry rates. That could be very useful. Or you have an environment where there's legacy clients that don't support maybe some of the newer Wi-Fi standards. This basically reserves the channel. So it's like, okay, a client's requesting to send, the AP says you're clear to send, and now the channel's reserved, and then the traffic's able to go out. So it's a protection mechanism. You see it used. If you see it in use, usually it means you have higher retry rates or legacy clients around, but some APs just have it on all the time. Okay. And then data frames, right? That's where you have your data payload, meaning, you forward traffic to the rest of your network. So that's going to be, unicast in a lot of cases. And the unicast data frames are sent at high data rates, right? So they might be sent at like, 800 megabits per second modulation speed or something, right? And so data frames actually don't usually use a lot of airtime, which is interesting to think about. Now you have multicast and broadcast data as well. That's usually sent at a much slower speed. Usually one of the basic data rates. And then the payload, as we'd said, right, that's generally going to be encrypted. Okay, so in a wireless capture, you'll see the data frame and who it's being sent to in the MAC header, but you're not going to see exactly what the application traffic is there. Okay. Just a visualization I think is interesting. I mean, again, this comes from our YBot sensors, but you could see the kind of the breakdown, right, of how much of your traffic is almost always not data, right? I mean, in this case, the data usage of the airtime is about 4%, whereas management is the biggest kind of airtime user. Now, this is 2.4, which is sort of notorious for a lot of that overhead. But that's kind of what it's going to look like, right? So again, in a packet capture, you're going to see mostly things like management and control traffic, and not as much data traffic. And the data traffic that is there is sent at a higher speed, so it doesn't, stay on the air as long, right? Okay, so we're going to continue talking about Wireshark here. Some of the ways to efficiently use Wireshark, right? Customization in terms of coloring filters, templates, display filters, things like that. So as you can see here, right, we have a nice little GIF showing us clicking around Wireshark, dragging columns over. So it's very customizable, right? You can change, for example, the columns that are being displayed. You can create new columns by like right-clicking on a field and then saying add as column, and then you'll have a column that says the data rate or something like that, right? And then also coloring rules. You can resize things. I mean, it's a nice little thing here to deal with. So the coloring rules, though, this is a great resource for everybody. So if you don't already have some sort of template set up for Wi-Fi, I really recommend you get one because it makes it much, much easier to sort of interpret and visualize what's going on. So MetaGeek, a great company in the industry, does have a Wireshark template that is very popular. So we figured why not just kind of link to that. That's a great resource for everybody. I use it personally. I've customized it a little bit sort of beyond the default, but it's great. It's a great place to start. So check that out. Go to this link. You'll be able to get that and use it for your Wireshark. And also there's a GitHub repository. So I know we're really focusing on Wi-Fi captures today, but there's a whole bunch of other coloring rules and templates and things like that out there for Wireshark. So this GitHub repo is another good resource for you. Okay. Um, so and then filtering, right? That's the other skill. Um, so the reason it's important is as I said, you're collecting like a flood of packets, right? And sometimes you're just looking for one specific client, right? Or you only want to see a certain type of Wi-Fi frame, um, things like that. So display filters are really the way to do it, in my opinion, right? Now there is another way to do that, which is called a capture filter. Okay, so when at the time of capture, you say I'm only capturing and saving frames of a certain type. That can be useful if storage space is at a premium. I would say it's better to do display filtering usually because a lot of times what you're looking for, I mean, you don't really know what you're looking for until you look. And if you're kind of cutting off some of the things at the time of capture, you might miss out on an interesting frame that maybe is using a lot of the airtime or something. So display filter is the way to go. And again, another resource, just to plug here, SemFile Networks has this awesome reference sheet. Again, something I just have bookmarked and I go to all the time. And it's got really all the common, display filters you can just copy paste into Wireshark, so you don't have to memorize most of this stuff. All right, so let's talk about the filtering syntax, though, just to see if everybody can kind of follow this. It's a little, maybe a little strange. It's not that weird. I mean, once you get a hang of it, but it's very structured, right? You'll have like basically a protocol field, an operator, and a value, right? So in this case, we see HTTP.host, okay? So the host field within the HTTP protocol, the equals operator, which is a double equals sign in Wireshark's case, and then you put a value, right? So it's going to do a string match for whatever you're putting in here. And then you can actually combine filters together, right? So you could filter for and or not, right? So some of those kind of standard logical operators, regex as well. I mean, so you can really get very complex with your filtering, and again, it's a skill set you can develop and be able to do some pretty cool stuff just with filters. But here's just a simple example, right? So you might be looking for a client with some, this arbitrary MAC address on, the Wipeout Webinars SSID. So this is what that filter looks like. It's wlan.addr double equals MAC address, and right there's your operator, wlan.ssid Wipeout Webinars, right? And that's gonna, filter through the capture and then show you only packets that match this condition. Okay. So that's high level how filtering works. We'll touch some of that in the live demo. Some other info we have in Wireshark that's maybe not so commonly known, right? There's this little tiny circle in the corner. If you click on that, it's kind of an interesting icon. It's not intuitive to me that this means expert info, but that's what it is. You click on that, you get what's called expert information. That could be useful in some cases because sometimes Wireshark just sees something really weird, right? Like malformed packets, things like that. So if you click on that, you'll get a little pop-up window that just kind of highlights some of those things. So it's stuff you might have missed just using your typical sort of methods of filtering through Wireshark. So click on that and kind of see what you see, right? Sometimes it's very interesting what you find there. Another one I really like is the WLAN traffic statistics view. So that's at the top of Wireshark. You'll have your the wireless drop down and the WLAN traffic. And that'll pop up this window, which gives you a nice breakdown because it shows you the percent packets, percent retry rates, and counters for the various BSSIDs that are out there. So if you're really trying to figure out which of the SSIDs was the busiest or where that client with all the retries was, pretty cool, right? And you could filter, of course, by the column headers and sort of sort it out to figure out what's what. But again, be aware of this. It's a nice function to have. And this one, Adam, my counterpart, is very excited about this. So I mean, this is another way to visualize packets where you're now doing sort of a graphical view of the number of packets per second over time. You can also apply display filters to that. So if you want to see in this example, right, how much traffic was on the guest versus how much traffic was on TLS by the packet count as your y-axis, you can do that, right? So pretty cool, pretty advanced, I would say. But again, I mean, Wireshark's a powerful software, so be aware again that you have these options. Okay, so I think it's high time that we get into some real world examples, right? So, um, Adam, if you don't mind, I'll let you kind of do you want to take over the screen share as well?
Yeah, I'll take over the
Okay.
screen share and I'll share out some actual examples going through some PCAPs here.
All
Yeah,
right.
so
Well, I'll stop my share and put myself on mute.
all right, thank you very much, Jacob. Yeah, so I'm gonna go ahead and start sharing my screen here, and yeah, so we've talked about a lot so far, using different filters to look at different things, using coloring rules, but let's actually put some of that theory to practice and look at some real packet captures. Before we start diving in, I do want to explain how you apply those coloring rules to begin with. There are two methods you can use. The first of which is to simply extract any zip that you get for coloring rules into your Wireshark's profiles folder. Now, on Windows, it is found in your app data, roaming Wireshark profiles. On Unix, Mac/Linux, it's going to be in one of these two locations, 50/50, depending on your operating system, but that is definitely one of the routes. The other route we're going to dive into when we actually open up Wireshark. So let's go ahead and do that. Now, as a recap, we do have all of these examples on our support article for this webinar resources slash Wi-Fi forensics 101. We're going to be diving into example one first, and those PCAPs, you can just download them and open them up. They should be all little 5 MB files, so you don't have to deal with multiple gigabytes that you're playing with. And I'll go ahead and do exactly that. So I'm going to follow this link here, and it's going to open up this page. I'm going to scroll down into where we have our packet captures. And I have these broken out into the 4 different examples that we'll be going through with an additional hint that gives you the kind of answer on some good filters to use and some additional advice with them. But I'm going to click this link and we'll pop them open here. Whoa, this is a lot of information. Now, this is one thing to be aware of with Wireshark. At times, it can be very intimidating to look at, and especially if you're not using some of the tips that we've already mentioned, coloring rules, filtering, it is overwhelming. And I have this set up in the default state without any coloring rule applied. To install coloring rules through the user interface, you can go to View, Coloring Rules, and there's an option right here to import the zip file that you download. Now, I already have all mine in, so I'm going to switch to the helpful coloring rule for this topic at hand, which is Wi-Fi analysis. So in the bottom right here, I have this option to switch between profiles, and I have my favorite one called Wi-Fi colors. So I'll go ahead and click that. Much better, much easier to sift through, and it actually is going to show the columns that are set up in that profile. And if you make changes to it, it'll save that for next time. Think of these as like different accounts almost that you can have in Wireshark. I mean, profiles is kind of the best word for it. Now, the problem that we're going to be dealing with for this first example here, if I flip back to the actual slide deck, we have a user who's complained about disconnects. So we need to see those disconnects, but it is also important to restate that you do not need to dive into PCAPs to see this. Disconnects are sometimes very easy to show. Our sensor for sure will show you disconnects on both the issue detail section and device forensics. But in this case, we want to prove it either to the AP vendor or maybe the device manufacturer that's at fault. Who's at fault? Well, let's find out. So the MAC address that we're going to be using for this first client, I do have as part of the example here. I will copy that to start with. And in Wireshark, well, we could filter right for that particular client, but why don't we start by filtering for disconnects in general, deauthentications. This is where another link is going to come in handy. And the thing Jacob mentioned that he has bookmarked the actual filters page. So I'll go ahead and open that up here. And we have a lot of different filters that we can use. Deauthentications, for example, is right here in the management frame section where I can just copy and paste this. So I'm going to copy it and we'll paste that up top into the filter bar. When I press enter, it has now filtered that entire packet capture to only show me the frames that match, well, the deauthentication subtype here. Now, it is important to note if you have a typo, like if I remove one of these two equals, you'll see the bar turns red. That's Wireshark saying, hey, heads up, you have a syntax problem. You need to correct this so I understand what you're trying to say. If you do run into syntax problems, this is usually pretty easy to correct. There's a lot of different examples that you can find out there for how to properly do the formatting. The kind of weird thing is you have to have two equals for this particular one. And what's happening with this deauthentication? Because we can see it says deauthentication here, and it's nice and bright and red, making it very apparent. Well, this is where we might want to open up the packet itself. And we can do this by either double clicking the packet to open that individual packet, helpful if you want to have more than one open at once. But I personally prefer to use this bottom section down here. I usually drag it up and start to expand out the different portions. So if I click through different packets, you'll see it's updating this information. Let's look at this first one. We can see in the actual data payload here that the client was disconnected because they had, or rather, let me rephrase, they were disassociated because of excess number of frames that need to be acknowledged. So this is the AP saying, hey, I heard, or I sent you a lot of packets, you're not acknowledging them, you're not connected properly. Let's disconnect you and try to get you on a better AP, or just re-authenticate to fix that communication. This, in a lot of cases, will happen if a client has walked away. The AP saying, I don't think you're here anymore, let me send a disconnect to be safe. And we can actually already see some retries of that disconnect itself, kind of doubling down on the potential problem here. But this is where it might be more effective to filter for the client at hand, which if I go back to that example page, I do have right here. So I'm going to copy this. And the way that we filter for clients, it is on the filters example, but I just know it by heart because I use it so often, wlan.address equals. Now, when I do .address like that, it's bidirectional. So it's either packets they've sent or have received. And we're going to see all of those in this packet capture here. Now, this is another place that I want to really drive home the point of coloring rules. If I switch this back to default, who knows what's going on? I can see it's my Wiz light bulb that's having some problems. It's an IoT device. But are these retransmitted? Is this a problem? By using an appropriate coloring rule, we can very easily see that it is a problem. And it's called out by these kind of maroon packets here saying that they're retry. So we can see the AP is sending a packet to the client, access point client, transmit receiver, and the client is not acknowledging those packets, hence the disconnect. Now, another thing that I do want to point out while we're looking at this is a good place for the actual expert information to be helpful, because maybe, this is a really clear example. We just see a lot of retransmission, but you might have hundreds and thousands of packets that you're filtering through and trying to find a specific event. This button, if I click it, will pull up a nice little window here that tells me for my filter, because it's limited to my display filter, 86 of those packets were retransmission. And other side tip, if I look in the bottom right, I can see the total amount of packets in my filter. There's 20,000 packets in this packet capture. When we're filtering for this client, there's only 117. So 86 of those 117 were retransmitted. Yeah, definite connection problem. So that's the first example. And there are different ways that you can peruse this data. But this is a kind of cut and dry situation where a client is retransmitting and being disconnected. The problem in this case is actually the light bulbs. They just have really bad Wi-Fi chipsets and always retransmit. I've given up the battle trying to fix them. On to the next example, though. This one is on the other side. Instead of them being disconnected, they're having issues when they're trying to connect. And so this is a really nice way where we can show just the management traffic, show just authentications, and maybe show what's happening up until that point. Again, your sensors will call out, heads up, we saw someone type in the password wrong. They weren't able to connect as part of that. But let's go into the PCAP for fun here. So back to the examples page. We're going to grab example number 2 here. I'm going to close up my previous Wireshark so I don't get confused. And in this one, we're going to be looking for a different client. Now, we could filter to the client directly, but I want to show you something cool that we can do. If I go to that handy dandy filters link, I could look for management traffic specifically. But when I do this, you'll notice that it's a lot of information. We have beacons all over the place in here, and I'm looking for authentications. Where's my authentication? Well, maybe I want to look at all management traffic, but just exclude beacons. So I could do this. I could write and exclamation point to tell it to not or invert the filter. And then I can grab the beacon here. So I'm telling it in this case, and this is in the hints if you do want to reference this in the future, I'm looking for management packets that are not beacons. Enter. A lot cleaner. And we still have that blue because they're used for probe responses, but a lot of different stuff here. Now, I do want to actually filter the client in question because we have that complaint, a user who's trying to connect and they say it's not working. My device is normally able to connect, but it's just not working in this particular area. Let's grab their MAC address like we did before for the previous client. And it's going to be basically the same sort of example here. We filter for WLAN address This is definitely by far my most used filter. I'll use it for APs. I'll use it for clients. Just a great way to show the specific traffic you're looking for. And I really wanted to go through this example because I think it's interesting. We can show the communication process for this client. They're sending some probe requests and getting responses from the AP. I'm looking for the IoT SSID. Yep, here you go. And then we start the authentication process. Authentication, acknowledgement, authentication. Yay. And then we start our WPA handshake. So we're communicating the password back and forth here. And would you look at that? We get deauthenticated right after. Again, coloring rules, a blessing for this sort of thing, because I can clearly see as I scroll through deauthentication, deauthentication, and every single time it's right after that WPA handshake. So that tells me hey, it's probably the authentication being the problem. And again, we can actually look at the packets themselves to see the reason that the AP is disconnecting this client, a four-way handshake timeout. And again, our sensors will show you the reason code in those signatures, so you don't need to dive this deep, especially for something as kind of, I would say, cut and dry as this. The way I actually caused this, I changed the password on my SSID, and then I had some clients that had the old password still trying to connect, and we can see that very clearly in here. So you can filter for authentication, deauthentication, management traffic specifically, filter for a particular type of management traffic, or maybe two types, excluding one of those types. You can even go to the level of using parentheses in here to do some really interesting concatenation and grouping of different filtering rules. It's similar in a way. I kind of think of it like when you're using Python or something like that. They're just kind of like if-and statements to a degree. So this is the authentication example. The next one I want to dive into here is more of an AP configuration problem. Now, in contrast to the previous two were done on the specific channel the client was communicating on. This one here, I actually grabbed this packet capture from the third radio in the sensor, which, as Jacob mentioned earlier, is the scanning radio. Its goal is to actually go through all channels to give us an accurate report of what all of the APs are doing in the area. And so as I scroll through here, I want you to pay attention to the channel column. Channel 2, channel 3, channel 4, channel 5, 6, 7, etc. It's flipping through them all. Now we see a lot of different stuff in here, this Netgear, this AT&T, this main, and then my actual Wi-Fi network, which yes, is very boringly named Wi-Fi. One of my neighbors, funnily enough, did this, not your Wi-Fi after I named mine that, but we can filter for the SSID we care about. Now this one, it's also pretty simple. You just do wlan.ssid. If I type correctly, equals equals. It is important to note that capitalization does matter. If I did Wi-Fi with a lowercase f, we're not going to find anything. But if I do an uppercase f like it is properly, we have my packets here. And what I want to show you is down here. So I have an AP that's on channel 1. We can kind of hear it on the adjacent channels as well. But then I have another AP on channel 11 at this moment. There is a key difference in their data rate, but I don't see data rate on here. How do I know there's a key difference? Well, because I made this example ahead of time. I wanted to set it up in this way to show you you can enable, disable columns as needed. One of the ways to do it, as we showed in the GIF earlier, you just right-click the top here, and then you can apply that as a column. So now we can see data rate of 1, data rate of 12. Alternatively, another good way, if I uncheck this, I could do it from the actual packet information. I could right click it down here and apply that as a column. And so you can even apply as filters from this sort of stuff. Wireshark makes it super convenient to navigate through in an efficient way once you get used to using it. Now here's the big difference. This AP, its beacon is at 1. This AP is at 12. Why is that happening? Well, if we look into the actual packet information here, and I expand out the payload, it's in the tag parameters for beacons. We can see that the 12 megabit access point has a minimum data rate of 12, and it's using 18, 24, 36, 48, and 54. The other one, he's got all those minimum data rates enabled. And if we actually go back to my slide deck here, I do want to show you, this is something that, again, the sensors will definitely call out for you. They have a specific signature to say legacy data rates are enabled because you really don't want these enabled unless you absolutely have to have them on. So that's a nice way to look, not just for, the beacon difference or the beacon rate difference, the offered data rates, but even just like credential differences between APs, authentication differences, if one's using WPA1 versus WPA2. As Jacob mentioned, there's a lot of good information in these beacons. The last example I want to go through here for kind of this practical walkthrough is one of my favorite tabs If we close out of this one, we're going to go to the last example here, which is identifying multicast traffic. Now, multicast is not always a problem. Actually, you're going to see it on your Wi-Fi. You're going to see it on your network all the time. It's a problem when it's eating up more airtime than it should, taking down our Wi-Fi because of just excess amount that does not need to be there. Typically used for discovery of printers, Chromecasts, Apple TVs, any sort of device that does discovery over the network is going to typically use multicast. So we can see here the sensor's called out, whoa, we have a high amount, and this really is a high amount. Our total airtime on channel 1 was 95%, and our broadcast airtime, or the multicast portion, was 72% of that. Way too much. Now, let's open the PCAP. It's the last example down here. I'm going to click into it. And what we can do with this is, yes, filter for multicast. And having the color rule really helps see the multicast. But when you're working with a really large PCAP with a lot of different packets in there, you might be curious how much of this is multicast. That's where up top, let me move the zoom thing out of the way. Or here, I'll just drag this down. We can go to wireless WLAN traffic, which will show us for each BSSID, each physical access point, the percentage of packets and where they go. So here we have 100% of the packets in this packet capture from this one access point. If I open this up, we can now see that, this weird 01005E, FB addresses a lot of them. And then here, 333300. If you're not familiar with looking at this, those prefixes, the 01005E and the 333300, are MDNS prefixes for multicast. Actually, more specifically, this FB address is MDNS. These are all multicast addresses. And so we can see a lot of our overall traffic is in fact multicast. And we can even see one particular device here using a ton. So I find this really helpful to show just the ratio of packets, especially if you're trying to find the source of your multicast. Now, what are these? What is using this on the back end? I have found it really fruitful to sometimes legitimately Google the MAC address. Like AirPlay uses a common one. Chromecast sometimes do. MDNS is always the same one. And so you can really start to get down to the source of it. Chances are someone else has run into a similar problem in the past and done some research on it, posted on some forums. There's so much good information out there about troubleshooting different scenarios. Now, the other way we can show this is my other favorite portion. And this is a little bit outside of the scope of what we want to cover today, but statistics, IO graphs. The really cool thing about this is it's just a customizable graph that you can use over the entire packet capture. So what I actually have set up down here is in my little rules, I have two different lines across, one of which is looking for the coloring rule for multicast data. The other one was looking for specifically not that. And so I can show over the packet capture the actual amount of packets sent. And I have this right now set to show over a 1 second period. I could do a 500 millisecond period. I could go all the way down to 1 millisecond, but then it gets kind of crazy and you get like 1 or 2 packets. So really helpful way to analyze different traffic flows. Not always going to be something you need to do, but it's a fun thing to do if need be. And, you know, while we've been talking mostly about the wireless packet captures, the last note I want to throw out here is if you're working on TCP traffic, you're working on Bluetooth, for example, these different profiles can come in very, very handy. I had a really weird TCP problem that I had to troubleshoot a couple months back, and this better TCP default came in extremely handy for that particular type of traffic. But you can see it does really nothing for my Wi-Fi here because we're not looking at the TCP packets, we're looking at the Wi-Fi frames. So that's kind of it for the actual live demo here. If we go to my next slide, it's going to be the conclusion. If there's any questions, we'll go ahead and answer them in just a moment. But yeah, thank you for listening to our technical spiel. Mike, do you want to go ahead and take it away?
Yeah, loved it, Adam. You made it more fun than my college professor did. So props to you and Jacob. Thank you for the webinar. Just some quick notes to everybody who attended. Thanks again for coming. Our next session is going to be on another interesting topic. Why bot DEX agents? So this is another angle of Wi-Fi optimization where you have hybrid workforces, you have staff who are on Wi-Fi networks that aren't in your control, or you want to be able to monitor their experience in Wi-Fi networks where maybe you don't have agents set up or the sensor set up. And so it's a solution from YBot that allows you to monitor, to put the agent on the end user's devices and monitor and troubleshoot from that perspective. So I'll put a link to it here in the chat, and I encourage you to register if you're interested in, again, hybrid workforce optimization, Wi-Fi optimization for the hybrid workforce. Will be a really interesting session.